1, 2. Good day, grade 12 learners. Welcome to today's mathematics lesson. My name is Analytical. The lesson is brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center and broadcast by Pagama Research and Development. Our lesson for today is analytical geometry, and we are basing it on the revision of our grade 10 and 11 analytical geometry. At the end of the lesson, we should be able to calculate the distance of a line segment using distance formula, calculate the gradient of a line segment. We should be able to observe the relationship between gradients of parallel and perpendicular lines. We should be able to solve problems applying the distance formula. And we should also be able to calculate the midpoint of a line segment, and we should be able to solve problems involving the midpoint, and we should be able to calculate the angle of inclination of a line. Here is the formula that we are going to be using for our analytical geometry problems. We have the distance formula. It is given in our formula page, and sometimes we use AB is equal to the square roots of x2 minus x1 squared plus y2 minus y1 all squared. That's the other version of our distance formula, but the naming is always dependent on who is using the formula. Our midpoint formula, you'll observe we are dealing with a line segment AB, therefore we have used A and B there to represent the X value at A and the X value at B, as well as the Y value at A and Y value of B. That will give us our midpoint there. We move on to the gradient formula. A gradient, sometimes it is known as slope, sometimes it is known as an incline, and we should be able to use the gradient formula. And most of us normally make a mistake with this formula, but we will get to it in no time. Parallel lines, we know that parallel lines have equal gradients. We also have our perpendicular lines. We know that the angle between the lines will be 90 degrees, but we use the term perpendicular, and we know the symbol for perpendicular. It is the one that is given there. We move on to the equation of a straight line. Y minus YA, sometimes given as Y minus Y1 is equal to M, where M is the gradient of that particular line segment, and X minus XA or X1, depending on the coordinates that we are using. That is a point that lies on that particular straight line. We look at the angle of inclination. We know this one also gives us some bit of a challenge. We know that the gradient of a line is equal to the tangent of that particular angle. And to get, we know how to use trigonometry to get our angle. If our gradient is positive, our angle will be acute, meaning it's greater than 0 but less than 90 degrees. If our gradient is negative, we know that our angle is obtuse, between 90 degrees and 180 degrees. We have another concept under analytical geometry, collinear points. These are points that lie on a straight line. And the common characteristic that we have is that they will have the same gradient. Hence, we use gradient to determine collinear points. We know our number systems, our number line. We shall be using this a lot. The concept of average gradient, we know how to find average gradient between 2 points. We know gradient of linear functions. We did this in grade 10 as well as in grade 11. We have used Pythagoras theorem from grade 9. We have done algebraic equations because sometimes we have to solve for a variable, hence we need our knowledge of equations there. Algebraic expressions, we shall be substituting coordinates of a point, either the x value or the y value, in order to get whichever variable we need to get. It could be an x or it could be the y value. We are going to be doing that. We also have trigonometric functions where we know how to calculate our angle using our calculators, and we shall be using our gradient to determine the angle of inclination. Example 1. We have a distance and midpoint formula. This I'll go over it very fast because we have done this in grade 10 as well as in grade 11. What I need to emphasize is that the coordinates of point C, you will realize that if we draw a vertical line, it will have the equation x is equal to 1 at point B, meaning the x value at point C will be the same as the x value at B. And if I draw a horizontal line from point A, I will have the equation of that particular line will be given by y is equal to 2 for this particular example. And then from there, it means the x value at point C is going to be the same as the x value at point B, and the y value at point C will be the same as the y value at point A, and I'm able to write the coordinates of point C as xb xb and ya. Sorry about that. So it will be xb and ya, so that we are able to see the coordinates of those particular points. I will move on now and say we are going to determine the length of AC by subtracting the y value at C. We subtract the y value at A from the y value at C, and I have indicated that. So AC is the horizontal distance. If you look at that part, horizontal distance, our x value at A is going to be -3, and our x value at point B is 1. 1 minus -3 will give us our distance as 4 units. And if we look at the vertical distance BC, we are going to subtract the y value at B. We subtract the y value at point C. And we said the value at YB is 5, and the value at point C, the y value at point C, we said it's 2, and that will give us the distance. Now, we have AC in terms of X, we have it as XB minus XA, and we got it as 4 units. And we have our BC as YB minus YA, and we have it as 3 units. And if you check, we now have a right-angled triangle there. And what comes into our mind? If we have a right-angled triangle, I know, you know it. We know what to do next. We are having a right-angled triangle, and we know that AB becomes the hypotenuse. Therefore, we are able to recall one of the famous theorems that we use in mathematics. And we know that, who can tell us what is the theorem that we have in given any right-angled triangle? Please, you should also be able to say it in words. Let's have it. So we are going to be using, to find AB, we are now going to use theorem of Pythagoras. The square of the hypotenuse is equal to the sum of the square of the other 2 sides. I know most people can't recall the Pythagoras theorem. They can only write it down. Please, you must know it by heart so that you know what the theorem says, and it's easier to use if you know what it represents. Now, I will do my substitution. It's AB squared is equal to AC squared plus BC squared. And then my AC is 4 units. My BC is 3 units. We substitute, and you can see I've done it on the other side using my coordinates at point A, B, and C in order to get the formula. And you are able to see that this is close to what I have highlighted on the first slide on our distance formula. It's given by AB is given by the square root of XB minus XA squared plus YB minus YA squared. We shall move on to the next part. There we have our distance formula. We move on to the midpoint formula. Average gradient. If you are given any 2 points, we know that to get average gradient, we just add the x values at the given point. We divide them by 2 because you are having 2 points. Hence, for our average, it is the number of items divided by the number of items. In statistics, we talk about data items. In this case, you are only having 2 coordinates. So you add the coordinates at the beginning and the coordinate at the end. You divide it by 2 because there are 2 of them to get the average. We move on, and we will, for us to get the average of the x coordinates, you shall add the x coordinate at A and the x coordinate at B, divide by 2. In this case, we'll have -3 added to 1. We get -2, divide that by 2, we will get -1. To find the average for the y coordinates, you are adding the y coordinate at A and the y coordinate at B, and then you divide them by 2, and that will give us 7/2 or 3,5. Now, so the average of the coordinates A and B are what are going to give us the midpoint of the line segment AB in this particular case. Now, we will get our midpoint as you have seen it. It's going to give us that as -1 and 7/2 or 3,5. That's the midpoint of this particular line segment AB. Now, there we have derived the formula again using our points that I have highlighted above, points A, B with -3 and 2, and point B with coordinates 1 and 5. We move on to the gradient. I indicated that gradient of a line is the slope or incline of a line. We know that the steeper the line, the bigger is the gradient. If you are going up the stairs, you know that if the stairs are steep, it is difficult to climb over those steps. And we are seeing that it is change in y over change in x. So, if our change in y is bigger and our change in x is smaller, then it means our gradient is going to be a bigger value, and the incline becomes even steeper. Those are the terms also that I use in relation to gradient: incline, steepness, slope. Those are related to gradient. And we should be able to observe that for this particular line segment AB with coordinates A, -3 and 2, please do not make the mistake. It's change in y over change in x. If you are starting with the y coordinate in B, please make sure that when you divide, you should also start with the x coordinate at point B. And you will realize that YA minus YB will be the same as XA minus X at B. The order should not change. You can start with any of the coordinates in the line segment, but you should be careful that the order is maintained. Otherwise, we will get a wrong gradient. I will move faster. We also have gradient as an important concept in analytical geometry because we use it a lot when we are looking at parallel lines as well as perpendicular lines. It was discovered that we all know that parallel lines are always an equal distance apart. So one of the characteristics of parallel lines is that they will have the same distance apart, meaning if the gradient of one line is 2, it means the other one will also have a gradient of 2. Otherwise, if the gradient changes, the lines are going to intersect somehow or are going to diverge further. Hence, parallel lines are going to have equal gradients. I know we have been using this one, but just to confirm this, I have A with coordinates -6 and 2, B with coordinates -2 and 8, and I've got C with coordinates 4 and 3, and D with coordinates 8 and 9. If we quickly calculate the gradient there, we'll realize that the gradient of AB will be given by 8 minus 2, which divided by -2 minus 6, and that will give us 6/4. When we simplify it, we get 3/2. The gradient of CD, we will take 9, subtract 3 over 8 minus 4, and we'll realize that we get the same answer. This confirms that, this is the observation that we are supposed to confirm. I've already said it. So you'll observe that the gradients are the same. And the gradient of parallel lines, we say they are equal. We move on to the next concept. We need to calculate the gradient of CD and EF. We also want to check what is going to happen there. So CD, we have already calculated the gradient. We found it as 3 over 2. Let's calculate the gradient of EF quickly. We will quickly do the substitution, and we are getting the gradient of EF as negative 3 over 2. Sorry, the gradient of F is negative 2 over 3. Then, what do we observe? Another concept that we have learned in our earlier grades, 3 over 2, 2 over 3, what do you call those fractions? As we are dealing with fractions, yes, you will recall that these are reciprocals. You multiply 3 over 2 by negative 2 over 3, we will get negative 1. But remember, in a reciprocals, the product is always 1. But this one is a special case because these are perpendicular lines. When you multiply the gradient of EF and the gradient of CD, we realize that we get a product of negative 1. And this is what we are going to be using going forward. Right. So we are able to conclude that the gradient of perpendicular lines are negative reciprocals of each other, and that gives us negative 1. Right? This is just a way of reminding you about reciprocals. We did this in our earlier grades, and this also is going to help us realize, especially when we get to circle analytical geometry, where we will be busy finding the equation of a tangent, equation of a circle. We shall be using this concept a lot. So please make sure that you go back, you revise these reciprocals and how to quickly get them so that we are able to move faster when we get to that section later on. Now we are able to see that the product is negative and these are reciprocals, negative 1. We shall look at this as we move forward. Quickly calculate the reciprocal of negative 2. You will realize that this will give us negative 1. And from this, it means if the gradient of one line is negative 2, if it is perpendicular to another line, the perpendicular or the gradient of the other line will be half. And we are able to see that this will always work. As you can see, once you multiply the 2 and get that, it will help us get our gradient. Now, we move on to the type of questions that we are going to be seeing. As an example, we are given that a straight line is passing through a point with coordinates negative 2 and 5. And parallel to a line which has the equation x plus 2y minus 6 is equal to 0. There's some bit of work that we need to do there, and you can see this is 4 marks. So, what will be our starting point? Looking at this, we looked at the equation of a straight line, and we mentioned that the equation of a straight line, the other version is given by y is equal to mx plus c. You will recall that that's the equation of our straight line. Now, but this equation is not given in standard form, so our starting point will be to make sure that we do some algebraic manipulation there in order for us to get the equation of our straight line, and we are able to get the gradient, and we use the concept of parallel lines. So I will now change that one. It will be 2y is equal to negative x plus 6. So we need to make y the subject of the formula, so it becomes y is equal to negative half plus 3. We divide throughout by 2. We did this from our grade 10 and 11 work. Now, so it means the gradient of this particular line will be given by negative half. It's given by negative half. From there, we know that the gradient of a line, I'll use L for the line, times the gradient of a line that we do not know, and it's parallel to this particular one passing through a point. Let me name that point as point D. So I will have the gradient of line 1 parallel to line 2 passing through point D. So we know that the gradient of line 2 will also be equal to negative half. And reason, we know that parallel lines have equal gradients. So I'll use M for gradient because we use symbol small letter m for our gradient. So from there on, I will now use the coordinates of that point D to help me find the equation of the other line. So this will give me y is equal to negative half plus c. I'll then use the coordinates of point D, which are negative 2 and 5, to help me get the equation. I will substitute. In place of y, I'll put 5. In place of x, I'll put my negative 2. And then I'll get my c as, what will we get as our c? We'll get our c as, this gives us positive 1. When it jumps the equal sign, it becomes negative. So our c will be equal to 4. And the equation of the other line will be given by negative half x plus 4. As you can see, the gradients are the same, and because they are parallel lines, the gradients are going to be the same, and the equation will be given by this. So it is important to remember our algebraic manipulations that we need to do in order to help us answer these questions. We move on to the next example. We are given the following points. K has coordinates negative 3 and 5, L has coordinates 2 and negative 3, and N has coordinates 5 and negative 9. They lie on the same, you want to determine whether they lie on the same straight line. And remember, I mentioned this part that if points lie on the same straight line, we call them collinear points, and they will have the same gradient. So my starting point will be to find the gradient of any 2 points. Let me find the gradient of KL. So I'll start with the coordinates of L. It will be, my y value at L is negative 3 minus the y value at K, which is 5, over the x value at L is 2 minus the x value at K, which is negative 3. And then this will give me a gradient of negative 8 over 5. I then have to take another line segment. Let me take LN. My y value at N is negative 9 minus the y value at point L, which is negative 3, over the x value at N is 5 minus the x value at L, in this case, which is minus 2, and this will give us the gradient of -9 minus -3. It becomes -9 plus 3. That gives us -6 over 5 minus 2 will give us 3. And this will give us an answer of -2. Do we need to look at Kn? No. Already we are able to see that the gradient of KL is not equal to the gradient of Ln. So it follows that K, L, and N, these are just points, but they do not lie on the same line. So this is one example where we need to make sure that we quickly do the calculations and we conclude very fast whether what the question is asking, we are able to get the solution for very fast. So the gradient of that is not equal to that. Therefore, we can conclude that therefore K, L, and N do not lie on the same line. Because our reason, I've already written it first, the gradients are not equal. Because collinear points, the characteristic gradient must be the same. Even if you have used Kn, you will find out that the coordinates of K and N, you'll find out that the gradient will not be the same with the other two that we have just calculated. Now, we move to the concept we're introduced to in grade 11. We are having our angle of inclination. I've talked about the angle of inclination, but by definition, angle of inclination is the angle between the line and the positive x-axis. We know that when we are dealing with analytical geometry, we are always dealing with the Cartesian plane. That's our x, that's our y. Our line makes an angle with the positive x-axis, that part. That's the angle of inclination. Not the angle below, not the angle on the left, but it is the one above the line, except for the increasing line. You will find out that the angle is between the line and the x-axis. Please let us be careful with that. We are not calculating any other angle. It has to be always between the x-axis as well as the line segment that we are dealing with. Now, the gradient of a straight line will always have a unique inclination angle. You will see as we answer questions, and we are going to do more questions based on this. And we normally apply this where we are having triangles and we have to get missing angles. We should apply our trigonometry and our Euclidean geometry correctly there. If our gradient is greater or equal to 0, on our calculations, we know that theta will be given by, we shift, turn, and then we put our gradient, we will get the angle of inclination. I have indicated that if our gradient is positive, we will have an acute angle between 0 and 90 degrees. It will be a positive angle. But if our gradient is negative, we will have our angle. If we just punch it on the calculator, it gives us a negative angle. So the easiest way, you add 180 so that you are able to get the obtuse angle that you need to get. Alternatively, I know, as we are taught in schools, we are told to ignore the negative sign. For example, if I have my gradient as -2, I'll have tan theta is equal to -2. We are taught to ignore the negative sign because it determines the quadrant where our solution lies in for our general solution in trigonometry. So for me to get theta, I will say theta will be given by tan of, if you put -2, then you add 180 degrees. This will give us our angle, which is obtuse. Alternatively, we are taught that we ignore the negative sign, and I can still get my theta by saying theta is given by 180 minus tan. In place of my gradient, I ignore the negative sign and put +2 there. I will still get the same angle of inclination. If I'm putting the -2, I'm adding 180. If I'm ignoring the negative sign and just putting the gradient as a positive value, it means I'll have my angle as theta is equal to 180 minus tan shift. I get my angle there. We move on. I've given you, so it means for this angle of inclination, we might be given the equation of a line, or we might be required to calculate the gradient of a line. And you will realize that the equation of a straight line can be given as that, or the other one. I have talked about this. And the angle of inclination, as I have alluded to, will be given as the steps. This is just an indication, an example using gradient of 1, and the gradient is positive, and we just shift, tan inverse, put your gradient, and we'll get our theta is 45 degrees. That will be our angle of inclination. It means in this particular instance, our angle, that's our x, that's our line, and we get our angle of 45 degrees there. As you can see, this is an increasing line. It will always have a positive gradient. We move. Now, this is the approach to analytical geometry questions. I've mentioned some of the things as I was saying, so you'll understand. Please take note of the terminology used in analytical geometry, and we must know it. In some instances, there's a statement which says only analytical methods must be used. Please make sure you use these concepts: gradient, distance, angle of inclination. You have also mentioned midpoint. When you are supposed to answer a question using analytical methods, you must use the formulae that we have revised and that we have been introduced to in our studies from grade 10. Now, you must know the formula to best use to prove the basic concepts, e.g., terms like bisect. We know that it divides into 2. What comes into your mind? Midpoint. Perpendicular, we have talked about it. The product of the gradient is -1. So, the steps, you select the correct formula from the formula page and you label the given points. Sometimes, if you are told that it's a straight line, even if P has no coordinates, it's PQRS. If you have the coordinates of R and S, you are able to find the gradient of PS because you are linking that these are collinear points. Therefore, you are able to get the gradient, and you label accordingly. Use the coordinates as given. We substitute correctly into the formula. And we perform the arithmetic first. For example, if you see that it's an increasing line, when you do your arithmetic, you get a negative gradient. You are able to see that something is wrong there. You can quickly check it and change it. Now, the subtraction, the addition, sometimes we do not need to waste time using a calculator. We should be able to do the computations on our own. Number 3, Questions in analytical geometry often scaffold. We know that you may be asked, first of all, the question will ask you find gradient. After gradient, it says find the angle of inclination, something like that. You use what you have found in the previous question to answer the next question. Use the diagram effectively. Please add information. If you are having a shape and they are saying AB is parallel to CD, in that particular shape, indicate the parallel lines on the diagram. If I have A, B, C, D like that, you are able to see the order of how the coordinates are going. And if they're saying AB is parallel to CD, you indicate in your diagram so that you are already knowing what to use next. The gradients are the same and so on. Highlights the sides if you are proving perpendicular and so on. We have mentioned this part. And when you are answering questions, remember to conclude exactly what you are supposed to find. If the question says, show that the lines are parallel, don't just calculate the gradient and leave. You must conclude and say, therefore, these are parallel, and your reason becomes the gradients are equal. Now, we must use the correct wording as well, because we shall be proving shapes. Prove that this is a rhombus. What are the characteristics of a rhombus? How is a rhombus different from a square? We must be knowing those. Also, it must be remembered that the product of gradients of perpendicular lines is -1, and we know that we can use that to help us get the gradient. If the gradient is 2, if you have to find the equation of the perpendicular, you are able to say the gradient of the perpendicular will be -½ because we are using the concept, it has been proven. If you are supposed to prove that the lines are perpendicular, on your formula, if you have the gradient of AB multiplied by the gradient of CD, don't start by writing -1 as your answer. It has to come at the end. Substitute the given gradients and show that they give us -1. And if they don't give us -1, we know that they are not perpendicular. The equation of a line, I have mentioned, we have the two forms. The equation of a straight line, we have y minus y1 is equal to mx minus x1. We have talked about this, mx plus c. And we should also take care that the equation of a vertical line, if its x is equal to 3, when they say determine the equation of the vertical line, it will be given by x is equal to that value there. If it passes through 3, 0, as well as passing through 3, 7, you are able to see that the x value is the same. Therefore, it's a vertical line, x is equal to 3. And do not try and calculate gradient, because already we know that will be dividing by 0. 3 minus 3, change in x, the denominator becomes 0, and it's undefined. So the gradient of a vertical line is undefined. Therefore, you just take whatever is the x value along that line. The gradient of a horizontal line, for example, can be given by y is equal to t. Horizontal line, straight line. It can pass through different points. It can pass here. We have our 0 and 3. And somewhere here we have 7 and 3. We are able to now say the equation of that line will be given by y is equal to 3, because the y value is the same throughout that line. That's the equation of a horizontal line. Now, I've mentioned these quadrilaterals. Please make sure you know the distinguishing features of these quadrilaterals. How do you distinguish a square from a rectangle? You can use sides. How do you distinguish a rectangle from a parallelogram? You can use the angles at the vertices, adjacent angles. We know that if I have A, B, C, D, you are supposed to prove that this is a parallelogram or a rectangle. you know that in a rectangle, I must have angles of 90 degrees. In a parallelogram, my angles are not 90 degrees. So what will you do? You look at adjacent sides, get their gradients, multiply them. If they give you -1, it's a rectangle. If they don't, then it means it's a parallelogram, because the properties of a rectangle and a parallelogram, opposite sides are equal and a pair of opposite sides equal and parallel, you will find they are the same. And the other distinguishing features, in a rectangle, the diagonals are equal in length, they bisect each other, and in a parallelogram, they bisect each other, but they are not equal in length. So we should be knowing those: rhombus, trapezium, as well as our kite. We must be knowing the properties of those. We need to revise them and make sure we know, because the questions will be asking us to prove which shape we are dealing with. Now, I will ask you to look at the diagram below, and you are going to answer the questions. I will be giving you time to look at the diagram and you answer the questions that follow. So those questions are going to be 5 marks. So I'll give you 5 minutes to quickly answer those and we will mark them together. Okay, I hope we are done. Now, it is important to always read the information that is given together with the diagram. In the diagram below, M, T, N, and P are the vertices of a trapezium MT and P. We are able to follow the vertices of that trapezium. You can use colors to follow the trapezium so that you are able to follow what's happening there. What comes into your mind? What are the properties of a trapezium? Do you know them? Good. We move on. So we are also given that Tn is parallel to MP. Q has coordinates 1 and 1. The other coordinates are given up there. And we are told that Q is the midpoint of MP. PK is a vertical line and SPK is given as theta. The equation of NP is given by y is equal to negative 2x plus 17. Let's answer the questions. First one, the coordinates of K. If you look at K, the angle given there is 90 degrees. It means KP is a vertical line. So first, before you answer, do it on the diagram so that you know what's happening. The coordinates of K become 7 and 0 because that's the x value there. It will be the same as the x value at P. So I can write K is 7 and 0. I get my 1 mark. The coordinates of M. The statement said Q is the midpoint. Therefore, we should be using the midpoint formula to help us get the coordinates of M. So I will say x at M plus, what is my x at P? It's 7 over 2. I will equate this to the x value at Q, which is my midpoint, as 1. And I will quickly do the manipulation. X at M plus 7 is equal to 2. And that will give my x at M as 2 minus 7. That will give me negative 5. For the y value, I'll do the same thing. My y at M plus my y at P, which is 3. All this over 2 should be equal to positive 1. And then I'll do the manipulation. That will give me y plus M is equal to 2. And that will give my y at M as negative 1. So from there on, I'm able to get the coordinates of M as negative 5 and negative 1. As you can see, this you can just do the manipulation and get the coordinates without showing the working. You can still get 1 mark for the x value, 1 mark for the y value. It's only 2 marks. The gradient of PM I indicated on this one. If you check, M, Q, and P are collinear points, and I'll encourage you, in case you made a mistake in finding the coordinates of M, you'd rather use the coordinates that are already given there. It's safer. So I'll use small letter m for gradient. PM is equal to, I'll use the y value at P, which is 3, minus the y value at Q, which is 1, over the x value at P, which is 7, minus the x value at Q, which is 1. And that will give us 2 over 6, which gives us 1 over 3 as our gradient. For this kind of a question, you get a mark for the method and a mark for the answer. We move on to, I'll give you 5 minutes to quickly answer 1.4, 1.5, and 1.6. Right, I hope we managed to finish the question. Now, let's quickly check. We need to find angle theta. And from the look of things, theta is just standing up there. What is going to help us find angle theta? We said questions scaffold in analytical geometry. There's something that is going to help us find theta. I will highlight the triangle PSK. We know properties. We integrate Euclidean geometry, we integrate trigonometry in analytical geometry. Theta is an angle up there. Angle K, PKS, we are given it's 90 degrees. What can help us get that angle? There's something that we calculated. We calculated the gradient of MP, if I remember well. We calculated the gradient of MP and we found it as 1/3. And if you look at the line MSP, that can help us because once we find that angle, we'll only be missing that angle theta in that triangle PSK. So we will use the angle of inclination to help us find this angle. I'll name it alpha. So using the gradient, I know that my tan alpha will be equal to 1/3, and my alpha, because this is positive, it means my alpha is going to be acute. Shift tan, I will put my 1/3 there, and I'll get my alpha as 18,43 degrees. Are we happy? And then from there, if this angle is 18,43 degrees, that one is 90, the theta will be given by 90 minus 18,43 degrees. And I know these are sum of angles in triangle, and therefore my theta becomes 71,57 degrees. So scaffolding, remember what we used above, we can use it in the next question. It says, hence or otherwise determine the length of PS. Hence or otherwise. Hence is a connecting word in English. It means from what we have discovered above, we can use to help us get the length of PS. So to get the length of PS, I indicated we have a right-angled triangle there. We need to find the length of PS. And looking at my diagram, I'm able to find, because my K has coordinates 7 and 0, it means I'm able to find the distance PK, and I'll get it as 3 units. My Y value at P is 3. My Y value at K is 0. 3 minus 0 will give me 3. So the length of PK will be 3 units. I also have found something. In my triangle PSK, I have that angle PSK as 18,43. And if I check, that side PK is opposite. And if I look at my PS is opposite a right angle, meaning PS is my hypotenuse. And then I can go back to trigonometry. What can help me find that part? I will use the sine function, and I'll say sine 18,43 is equal to my opposite. It's going to be PK over my hypotenuse, which is PS, and I'm able to make PS the subject and have my PK. I'll substitute 3 over, I will divide by sine 18,43, and then I'm able to get the value of PS. Punch this on a calculator and we should get 9,49 units. We are done. So please, you don't necessarily need, because it was not specified that you are only using analytical means, hence we can use whichever method works there. It says hence or otherwise. You should be using your diagram. Also, we found our theta as 71,57. And looking at that diagram, I am able to have my PS. If I check, PK becomes the adjacent side to this angle theta, and PS becomes my hypotenuse. So which trig function has an adjacent and a hypotenuse? That is going to help me get the cos function. So still using the same method, I can use my cos 71,57 as PK over PS. I will also be able to get the same value of the length of PS. We move on to 1.6. 1.6 will require us to work a little bit. We are supposed to find the coordinates of n. How do we determine the coordinates of n? What information do we have? I will quickly go back to the first slide on the information. We are given the equation of NP. NP is given by y is equal to negative 2x plus 17. We all are able to see that. And then, if we look at that, NP intersects MN, it also intersects our T, which is negative 1 and 5. That line Tn. But we do not have the equation of that one. All we have is the gradient. So, to make my life easy, I have the equation, so I can write the coordinates of n as x, but I know that the equation of that line is given by negative 2x plus 17. And I have coordinates of t as negative 1 and 5. So what can help me get the coordinates of point n? In short, now I have the coordinates of n in terms of x. It's x and negative 2x plus 17. And I have got the line Pn, which helped me to get those coordinates. But I've got something else that can help me. I calculated the gradient of MP. I found it as 1 over 3. And Tn is parallel to MP. So I can use the gradient there to help me find the coordinates of n. So I will say my y value, the gradient of nt is equal to the gradient of PM. And we know that parallel lines equal gradients. And we know that our m in this case is 1 over 3. I'll use the formula for gradient to help me find. My y value at n, it's negative 2x plus 17 minus, I will also have my y value at t is 5 over, I will have my x minus my y value, my x value at point t is -1. And I will equate this to 1 over 3. From there on, I'll do my manipulation, and this will give me, on my left-hand side, I will have -2x. 17 minus 5 gives me 12 over x minus -1, that gives me x plus 1 is equal to 1 over 3. Then I will cross multiply, and this will give me -6x plus 36 is equal to x plus 1. And then from there, I will take the x to the other side. I'll get -7x is equal to 1 minus 36. That gives me -35. So I'm able to get the value of x. So divide both sides by -7. I will get my x as +5. I'll then take this positive x as 5. I will substitute into to get my y value. It becomes y is equal to -2 times 5 plus 17, and this will give me my answer as -10 plus 17. That gives me 7. So meaning the coordinates of point N will be given by, we are able to see that our x value, we got it as 5, and our y value is going to be 7, like that. That's why we need to do some bit of work and thinking, hence it is 5 marks, like that. Because of time, let me move a bit faster. 1.7. I will not give you time to do this one, but we will do it together. If you check, it says if A with coordinates A and 5 is on the Cartesian plane, write down the equation of the straight line representing the possible position of point A. I indicated this when I was giving the examples of horizontal lines and vertical lines. So it means along this line, we should have y is equal to 5. That's the equation of that particular straight line. And we shall move on to 1.72. That I'll give you some bit of time to do. I'll give you about 3 minutes to think about it, and you will answer it after. Please take note that point of saying A has coordinates A and 5. We should remember that point because we need it for 1.72. Now it says, hence or otherwise calculate the values of A for which TAQ is equal to 45 degrees. I've assisted you with 1.71. This one should be easier to do. I'll give you 3 minutes to work on it. Right. I hope we have managed to do something. I will draw my initial equation of y is equal to 5. And remember, it says TAQ. So as you can see, it starts from T. I will draw another line passing through Q down like that. And it can still go either to the left or to the right. I can also have point A being there, passing through Q as well. And what I know is that my A can be here, A and 5, or my A can be at that point, small letter A and 5. This angle here is 45 degrees. The other angle there is also 45 degrees. But what do I know? I've got my x-axis as well as my line y is equal to 5. And I know that that line y is equal to 5 is parallel to the x-axis. And I know that if this angle is 45 degrees, I'm able to form a z like that, meaning this angle of inclination will also be 45 degrees. And then, if this angle here is 45 degrees, this angle here will be 135 degrees, which also gives me the angle of inclination of that other line. I will call this one B, and I'll call this one C. Those points. So I'm able to get the gradient of AB. I'm also able to get the gradient of AC. And that is what is going to help me find the value of A for any of the given 2 points, as long as I have an angle of 45 degrees in the angle TAQ, I will be able to get the X value at that particular point. So what I'm going to do next, I'm going to say the gradient of my line, you can see AQC, or let me say the gradient of AQ will be given by tan 45 degrees, and that gradient will give me a positive 1. I've explained how I got that. Parallel lines, and I'm using the fact that this angle of inclination will also be given by 45 degrees. I indicated like that. 45 degrees. If I use this one as well, I form a Z. This will also be 45 degrees. And then from there on, I'm able now to find the gradient of my line A, B, Q, so that it's different. So my line AB, it will be given by tan 135 degrees, and that will give me negative 1. But now I have coordinates of my point A. My point A, I said it's 5. The y value is 5. The y value at Q is going to be 5 minus 1 over my x value is A minus 1, and that should give me a gradient of 1. From there, I'm able to get my answer. 4 over A minus 1 is equal to 1, and this will give me my A minus 1 as equal to 4, and I'll get my A as 5. Using the other angle of inclination. So to get the A value this side, because you can see that that point, if my X value is positive, it means it's going to be in the first quadrant, which is that point there. I then deal with the other one. I said I'm still using my X value is going to be 5. Sorry, my Y value is going to be 5 minus the Y value at Q, which is 1, over A. My X value at A is that one, minus the X value there, minus 1. And I said this will give me negative 1. And then from there, I'll have 4 over A minus 1 is equal to negative 1. And this will give me my answer as A minus 1 is the same as negative 4. And then from there on, my A becomes negative 3. So I've managed to get the values of A as negative 3 and 5. So the negative 3 is the one that will be in quadrant 2. And the value of A as 5 will be in quadrant 1. So I'll have 5 and 5. And this side I'll have negative 3 and 5 as the coordinates of that particular point A. Interesting question. And you will realize that these are the kind of questions that examiners ask. It's not only find the angle of inclination, you must do some bit of work. As you can see, that question is 5 minutes, it's 5 marks. There is another question, but in the interest of time, we will not be able to solve that one. I'll just highlight it so that you are able to take a peek. You will do it later on. It's also an interesting one. It involves our inclination. As you can see, the one that is interesting me the most is the last one, where we are supposed to prove that QBSP is a parallelogram. That is what I said. We should know the properties of these shapes, and we should be able to use those properties to help us determine whether it's a parallelogram or it's a rectangle. As you can see, it's 4 marks. So the length of PQ, we are using the distance formula. That one is not a problem. 5 minus negative 1, we get the answer. 13 minus that, we get the answer. And we should get our distance there using the calculator. It's not a problem. The gradient of PQ, we are able to get it. 13 minus 5 over 5 minus 5, we'll get it as 4 over 3. The equation of a line RS in the form AX plus BY plus C is equal to 0. We should be able to do that one. We got the gradient of PQ. Therefore, we use the gradient of PQ to get the gradient of RS, as those are parallel lines. And we use the gradient that we got, and we use the coordinates of point S to get the equation of our line. I suppose those who managed to do that question quickly, you will realize that the gradient of PQ is, we got it as 13 minus 5 over 5 minus negative 1, and we got it as 8 over 6, which is 4 over 3. Then we use the fact that the gradient of RS is equal to the gradient of PQ, because RS is parallel to PQ. Then we will get our equation as Y is equal to 4 over 3 X plus C. We use the coordinates of point S, which are 7, 5 and 8. We substitute. 8 is equal to 4 over 3 times 7, 5 plus C. And we will get our C as 10, this gives us 10. 8 minus 10, that will give us -2. So the equation will be given by y is equal to 4/3x minus 2. From there, to write it in standard form, remember the LCD, you should use the LCD of 1, 3, and 1 to get the equation. You will get 3y is equal to 4x minus 6. So you take everything to one side, you'll get 4x minus 3y minus 6 is equal to 0. That is the equation that we will get. Now, in the interest of time, we can quickly copy this question as our homework. As you can see, there are questions that are similar in almost all the questions. The unique one there is perimeter. So all those concepts, perimeter, area, we must also revise them in order for us to get the correct information and to help us answer our questions. Now, we can see that for our lesson, in summary, analytical geometry formulae and methods must be used to solve analytical geometry problems. The calculation of angle of inclination in relation to the slope of a line must be understood and we use it correctly. Euclidean geometry, axioms and theorems and trigonometry are integrated into analytical geometry problems and we should be able to use that. Properties of our polygons must be proven also using analytical methods. I indicated this one at the beginning. I thank you.